So first we will go ahead and import our libraries. We have TensorFlow. We have Keras, so TensorFlow. Actually, we want to say from TensorFlow, we want to import the following items: the datasets, the layers, and the models. And we want to visualize our metrics, so we will import and visualize the dataset, some of the data, some of the pictures. This dataset is a set of pictures. matplotlib.pyplot splt. Now, for those of you in this session, were you able to see that video that I referenced? Or the Adam algorithm? Okay, great. So the next thing we want to do is import our dataset. So from the datasets object, I will use the method load data. So cfar10. cfar10 dot load data. Let me show you what cfar10 is. It's a database of pictures, small pictures, and they are all uniform in size. Now this method will return training images, testing images accompanied by their labels. If these are terms with which you are not familiar, I will explain them to you in a moment. So we have train images and the train labels. Test images. Test labels. While this downloads, let me show you the CFAR database. This is it. There we go. It is a dataset that contains 60,000 pictures that are only 32 by 32, all color. And all of these 60,000 pictures fall into one of 10 classes. Here our focus is the fundamentals of neural networks. So once we cover this example and we understand why we have this particular architecture in our neural network, we will then be able to build upon what we know, and then we can work with other pre-trained models, or even come up with our own models. So we can go to research papers, and they will make reference to different types of neural network layers. But once we have a foundational understanding, we can create our own architecture and make sense of those research papers. So the pictures these are some of the pictures. They're very small, 32 by 32. Okay. Well, we are going to train a model that will be able to classify pictures like the ones you're seeing here. And they all have certain characteristics. So for example, the subject of the picture is in the center of the picture, like this car, this bird, this these deers, moose. We don't have any of these in Dubai, by the way. So elks, there we go. What do we call the class of such creatures? Deers, moose, elk. I think moose are quite large, right? I think they're the largest of their type. But yeah, all of these pictures have the object right in the center. So the model that we are going to build or train can only accurately classify pictures of this nature. Square in size, and the subject is clearly right in the center. And of course, it belongs to one of these 10 classes. So if you want to predict, let's say, I don't know, a basketball or a person, it will not be able to do so. Or what it will do, when we say it's not going to be able to do so, it's going to put them into the class that is closest, or the class that is most probable, which will be incorrect anyway. But again, this is the point here is not to create a production level machine learning model, but just to understand the fundamentals here. Okay, let's return here. Now that the dataset has been downloaded, it's right now in the environment, so I don't think it will appear here in the files and folders. So it's actually, they are downloaded into the memory, the temporary storage of the computer, the instance on Google Cloud. So if I were to type in ls, by the way, in Colab, you're able to work with 2 programming languages and of course Markdown. Markdown, we don't call it a programming language. If you want to work with the bash script, you put an ampersand. And this exclamation mark tells Colab that what follows after the exclamation mark will be bash script. So we can use the ls command to list the contents of what we have just downloaded. Or actually the contents of this folder. Okay. We won't need it in this example though. Let's carry on. Then we have the images in the form of a tensor. So if you remember, by the way, TensorFlow is built on top of NumPy. So data will be stored in the form of a NumPy object. And if you remember, we said that a NumPy object has 3 attributes and the data. So one of those attributes is shape. And here by shape, you mean the shape of the tensor. So I want you to imagine a tensor to be a collection of matrices. Let me show you a picture here. There's a glossary that I have created in a Word document, which I will share with you as well. Let me just, because I have the picture in there, glossary. I mean, you can see these pictures in Google, but I want to show you the one I found. Glossary. There we go. So this is a tensor. It's a stack of matrices, but it can also be a stack of columns. So you can arrange a stack of matrices horizontally or laterally, or in this frontal arrangement. So let's try to imagine our tensor of pictures to be this. So here, when I bring you back the notebook, it says here what? It says 50,000, 32, 3. What do we mean by this? We have 50,000 pictures, and pictures that are 32 by 32 with 3 color channels. That's what this means. And this is one tensor. So it's a sequence of tensors where each image is a stack of three color channels. Okay. Let's return. Let me look up the remaining code I have here. And the next thing I want to show you. Okay, also for the test. Now, of course, the data set that we downloaded has 60,000 images. Here it says 50,000. Where are the remaining 10? Well, they are in the test data set. Again, what's the purpose of training a test? Let me quickly also pull up this other slide, the slide from our last workshop. Tell you about test and train, and sometimes something called validation.